As I said, my name is Jonathan Ulysses Marino Carr, and I solved evolution. By understanding our evolution, our true evolution, this will help us understand DNA so much better. We will actually be able to program DNA, okay? It won't be this guesswork and we piddle around this and that. We will actually know how to program it. So if anyone that you know is suffering from some natural disease, such as maybe for cancer, for example, or acromegaly or something, or the pituitary problem, we will actually be able to cure these diseases. We will know exactly what to look for and how to disable it or enable it to be able to heal these people. Because if we know how our lineage evolved, we can locate genes and when they're passed. And when we can locate and isolate these genes, this will literally help us be able to program how we want something to be. I mean, literally. Alright, so it starts with the shark, which is the whale shark. Okay, this is the ichthyo, this is the fish, 2-chambered heart. The mammal, 4-chambered heart. Okay, all true mammals give live birth and have a 4-chambered heart. Anything else that is cold-blooded has to gain heart chambers over evolution to be warm-blooded, because it's all based on thermodynamics. Okay, and Peto's paradox coincides with this. The reason why whales don't get cancer, you'd think they'd get cancer because they're so big. No, they don't get cancer. It's because they're more cancer resistant. And the reason why is because technically they eat the world around them because they live on plankton and such like that. So they can adapt. And when you're dealing with a large scale like this, they are the macrobacteria. They were a macrophage, more or less. And we are microphages. We're bacteria or dwarfs that are basically dwarf genes passed through the lineages. Okay? So you have a lineage of ichthyosapiens, and you have a lineage of mammals. Okay, these ichthyosapiens have a mammal gene, which gives them a spine, and these mammals here have an ichthyosapien gene, which gives them shape or polymorphism. Okay, now I explained that gene in a couple of other videos. I'm just throwing it out. PRSS33 is the spine and teeth gene. CASP12 is a polymorphic gene. Okay, studying amphibians will help us understand this. The frog, that's the hips. Okay, that's the hip evolution. That's going to be a theropod. That's why birds walk on 2 legs, and they can't really use their wings. They can only flap their wings or have nubs. All right, this is a specialized spine. Okay, this is why newts have such a specialized spine. That's why it's so unique, and their facial muscles are so unique, because this is going to be the origins of where we're going to develop faces and spines and stature. Okay, so their stature, their cervical spine of a newt is special because this is going to be how evolution develops whatever stature of being comes along. It's spine. So we are a type of sauropod. See, when you combine a tetrapod and a theropod together, you get a sauropod. In the mammals, you take the theropod gene and the tetrapod gene, you might combine them, you get a sauropod, which is a type of human. We are a sauropod. There's a sauropod gene inside humans. Alright, now I'm going to start with the whale shark. The whale shark has 2 chambers, okay? Now, eventually, this 2-chamber, say it wants to walk on land, okay? And it's going to do this through a transitional state of amphibians, okay? Giant amphibians existed from it starts technically with this guy, okay? It starts technically 400 million years ago with the giant snakes, or the eel technically, or hagfish, the serpent. The serpent is what is going to give us our spine. Okay, this is going to give us, see, the hagfish is hermaphroditic. That means it carries the Y and X genes. Okay, it's hermaphroditic. They can change into Y or X. That's going to give us our genders. Okay, it also has no spine. It's all cartilage, but it only has a skull. Okay, so this gene, it barely has the keratin gene, but it's going to pass it. Okay, it's going to pass beta and alpha keratin. Why? Well, because it's a mammal. And it's a fish. It's literally a mammal and a fish, and it's male and female. Okay, this is going to split and give us our lineages. This is going to give us male and female genders, and it's going to give us fish lineage and a mammal lineage. Okay, giant hagfish or serpents, giant serpents that existed on Earth millions of years ago, are where our true origins began. Okay, stepping out in a few million years or 100 million years, whatever. Okay, the fish lineage, okay? This is going to be the Ichthyo sapiens. All right, so you have the whale shark, which is 2 chambers. It wants to walk on land, so it evolves into amphibians, okay, which have 3-chambered hearts, all right? But it still wants to be a warm-blooded animal, okay? What's it going to do? All right, so the theropod gene is going to evolve into birds, okay? Non-avian birds right now. Okay, so that theropod gene is like, well, I want to evolve into a 4-chambered heart. So it does, okay? Boom, the ostrich, okay? This is going to be the proto-embryonic state of what's going to be the raptor, all right? It wants to be able to use its forelimbs too. This is why the ostrich can run so fast and has such specialized legs, is because this is the hip and leg portion perfecting itself in the theropod or the Ichthyo sapiens lineage, all right? So the birds, they become a 4-chambered heart. But then it's like, evolution's like, man, those 2 nubs in the front, I got to do something with those. And then boom, the eagle or the raptors, the condors, 4-chambered heart, and they use their pelvic is all developed, and then they develop their wings, okay? So boom, now you have the theropod at its best, okay? Now the tetrapod, it wants to do the same thing. This tetrapod gene is like, well, I want to evolve into a 4-chambered heart. Well, how do I do that? It evolves into a platypus. All right? This is a mammal fish. It's an ichthyosaur. It's the Ichthyo sapien lineage, but it's the tetrapod equivalent, okay, of a mammal in this lineage. That's why the platypus is related to a bird, a duck, and it's venomous. Did you know a platypus has fangs? Oh, yeah. They can kill dogs and cats with their poison, very rarely humans, but humans say it's one of the harshest pains they've ever suffered. They have venom in their heels, in their feet, okay? So this is why they're venomous. Now, tetrapod also wants to say, well, I want to stay cold-blooded too, but I want a 4-chambered heart. So the tetrapod forms, boom, it evolves into alligators and crocodiles. The only reptile, the only true reptile, okay? These are true reptiles. The reptiles we have right now that lay eggs are technically a proto-amphibian. And that's an amphibious evolutionary state in between becoming a true crocodile. And the reason why they are actually amphibians is because they have 3 chambers, okay? The Komodo dragon has 3 heart chambers, not 4. So it's technically still an amphibian, not a reptile. It will not reach its reptile state until it reaches 4-chamber hearts, okay, and cold-blooded. So we're going to have to reclassify some things once we understand this, okay? So then the tetrapod and theropod gene are like, well, hell, man, you know, I want to fuse with him because he can use his forelimbs and his back limbs, all right? So a bipedal 4-chambered reptilian evolves. Where that thing is at, I have no idea. It just creeps me out because the possibility of it existing is real on an evolutionary ladder. Evolution literally did, whether it happened on Earth or not, or some other planet where evolutionary tree began, regardless. A tetrapod, theropod, 4-chambered heart has to exist. That's cold-blooded, okay? Just throwing that out there. And also, a warm-blooded 4-chambered heart reptilian could also evolve. So, millions of years in the future, I'm willing to bet about 3 million years in the future another gene is going to be passed. All right. So, in the mammal lineage here, you have the manatee that evolving from the whale. Then you have the cervical spine. Okay, this is going to be the shape, the polymorphic gene we're getting from the amphibians, the Ichthyo sapiens. Okay, the Ichthyo sapien gene or lineage. We're getting our spines. We're getting our spines from the mammal lineage. Okay, so they're giving us shape while we're giving them spines. See what I'm saying? Okay, after the seal or the walrus, those lineage of the pinnipeds, then you have hippopotamus. Okay, then that lineage. All right. Eventually, there's going to be another gene pass, and you're going to have an evolutionary response, which is going to have elephants. Okay, then the rhinoceros. All right. Then the even-toed ungulates, which are artrodactyls, and then the odd-toed ungulates, which are artrodactyls. All right. They are closely related to whales. Why? Well, because they are about this far away in lineage, okay? They can connect these, believe it. Why they have the manatee and the seal or the walrus completely cut out of the picture in this evolutionary state, in this evolutionary chain? I have no idea. Okay? Maybe they're trying to suppress it. Maybe they're trying to hide it. Maybe they don't even see the connections. But the manatee is the first step out of the ocean. Okay? It steps onto the land, and that's when this embryonic state in development has the umbilical cord after 6 weeks. Okay? This is the pinniped version on evolutionary scale. Okay? Compared to us, how we develop. All right? It mirrors our conception. How we develop inside the zygote or the womb is exactly how evolution forms, passing genes every 3 million years. Now, like I said, you don't have to believe all this, but science can prove all this. This is not a wild theory, okay? This is not a wild theory, and I'm not some crazy lunatic. This is real. This is the biggest discovery of the 21st century. Okay, the zebra, the killer whale, and the panda bear all share a gene that I like to call an apex gene. Okay, it's the black and white gene. This is what's going to give everything that's a mammal black and white color and all the shades in between. Okay, I'm just throwing that out there. Okay, I've also located, there's a divergence, all right? 140 years ago in Gondwana, there was an ancestor somewhere that is marsupial and ape. Okay, there's a divergence. Now, this happened 140 million years ago, all right? This is way before our lineage, because the lineage keeps happening. No matter what extinction event happens, the large animals never really die. Okay, they still live to pass on genes, which begins a whole new lineage. Okay, the root is still alive no matter what extinction happens. The root's still alive. So it's going to regrow the tree. And it's going to happen the same way. It's going to pass the same genes again. Okay, so you have the giraffe, which is an even-toed ungulate. Okay, and this is going to be where the foot is splitting in the hooves. This is where the keratin and fingernails and are going to basically evolve. Okay, see where the rhinoceros was a horn of hairs, and it split and gave hair and horns to all these ungulates. Okay, it's the father progenitor of all of the odd-toed and even-toed ungulates. Technically, I mean, all the giants are progenitors. We're all related to these, okay? We are a cattle, literally. We are in the cow species because we are a beast of burden, literally. Okay, also, we did not evolve from monkeys, okay? We evolved from apes. Monkeys are dwarf genes that are passed on from the ape. So monkeys evolved from ape, technically. I mean, you don't have to believe me, like I said, but I guarantee you, scientist starts doing some genealogy, he's going to find this out to be very, very true. And just understanding the simplicity of it, like I'm trying to give out to the world here, will reveal a whole new world to us. Okay, so after the rhino passes the gene and becomes all of the artiodactyls that are even-toed ungulate, there are over 270 land species, okay? These are going to diverge into subspecies. So you can imagine every one of these in this 270 splitting and diverging into its own subspecies. That's a lot of animals, okay? See, that is going to split and diverge into 17 species of odd-toed ungulates, okay? Which one of them happens to be apes, okay? And horses, zebras. This is where the fibula and the ulna are reduced. This is more or less, in this section, the arms and legs are going to try to start adapting because after we finally left the water, our ivory became keratin, hair and bone, all right? Our ivory disappeared. And the guts and the stomach are trying to perfect itself also, which I've been, see, like here, for example, okay? If there's 4 stomachs here. In the cow, what's the rhino? When in the cow, there's 4 stomachs. In one, okay? So it's like the stomach is trying to perfect itself. And if you actually look up each individual, you can see each organ getting better and better in all these animals. Because one animal will lack something, but it'll have more of something, okay? But then the next animal that comes along will have more of what the other one lacked while it's trying to perfect another aspect. You see what I'm saying? See, the mammal lineage, the way to tell that if something is a true mammal is it doesn't lay eggs. But women inherit the ichthyosaur gene from the shark. That's why they have eggs in their ovums. And that's why the shark's brain looks like a woman's reproductive system. So, but all mammals in particular give live birth. That's what we inherit from the whale. Live birth and 4-chambered hearts. Okay? The secret's in the heart. Or the secrets of the heart. The key to the heart. All of these analogies and things we say about the heart are true. The key to the heart and all of that, it's actually evolution. Understanding the truth about evolution. Okay? Anything with a 4-chambered heart that gives live birth is a true, born, original, through and through, from the roots mammal. Anything that lays eggs is a true and true, from the root ichthyosaur, ichthyosaurus, Mammo Sapien. So again, humans are Mammo Sapiens. Sapiens are Mammo Sapiens. Because their primary gene is the fish, and their secondary gene is mammal. Our primary gene is mammal, and our secondary gene is fish. So yes, fish do walk on the land. They evolved to walk on the land. So did the mammal. It did it through pinniped form. The fish did it through amphibious form. But lo and behold, all of it combines. We are originally, from the roots, were amphibious at one point in time in early history. 300 to 400 million years ago. So I'm just throwing that out there. My name is Jonathan Ulysses Marino Carr, and I solved the theory of evolution. So, like I said, if you have or know anyone that's sick or have had any genetic problems, inherited, we will actually be able to treat and study these with using gene therapy because we know our evolutionary tree, how it came to be, when and where specific genes were passed to give us a certain characteristic, okay? So by understanding this, we will be able to program DNA, literally program DNA. We can't necessarily program DNA. Now, we are on the cusp of it. We understand it a little more every day, but we do not understand how to literally program whatever kind of animal we want. If we wanted to make any kind of chimera, this is the only way to do it. We will actually understand how to make an animal, literally, by programming the animal genetically.